All right. So today what we're going to do is we're going to look at Project 4, and we're going to look at all the practice, problems just like the ones that are in Project 4 to help you out with your project. So let's start with the first one. So we're talking about function values. So it says the function f is defined as following. So it gives you this f of x equals 3x squared minus 4x, where and find f of negative 3. So really, there's a lot of stuff, and that looks really confusing. But basically, what they're saying is f of 3, if you notice, there is an x right here. Okay, and there's an x right here and right here. So basically, this negative 3 is replacing where the x's are. So f of negative 3, all we're going to do is we're going to put in negative 3 wherever an x is. So I'm going to put 3, and then parentheses, negative 3 squared, because I can't forget about that squared, minus 4, and then times negative 3. So that's all I do, is I replace wherever I have an x with that number or variable, and that's what I'm going to do for all of these three. Well, first off, since the order of operation says parentheses, then exponents, parentheses, those are in parentheses, but really it's the exponent. We have to do negative 3 squared. So now think about it. Negative 3 squared means negative 3 times negative 3. So what's that going to be when we do negative 3 times negative 3? Yeah, positive 9. So I'm going to go 9, and then we'll eventually times that by 3, minus, now I'm going to multiply this out. I've got 4 times 3, 4 times negative 3. Well, 4 times negative 3 is negative 12. What happens, though, when I have two negatives in a row? When I have minus, minus. Yeah, it turns into a plus. So that's important that you realize that those negatives cancel each other out and you get a plus. So we're going to get 3 times 7 is 27 plus 12. Well, if we add those two, 27 plus 12, 2 plus 7 is 9, 1 plus 3 is 3, or 1 plus 2 is 3. So we're going to end up getting 39. And that would be our answer. Okay? So all we do is we plug in the negative 3 into each part where the x is. So in this one it says g of x. Okay, we're going to kind of separate that. This one says g of x equals negative 2x cubed minus 8, where g of negative 5. So same thing. We're replacing the x with a negative 5. So I'm going to say negative 2 parentheses negative 5, because that's where an x is. I'm plugging this in for x, minus 8. Okay? Oops, forgot the cubed. Can't forget the cubed part. Okay? Now, cubed means to the third power. So I'm saying negative 5 times negative 5 times negative 5. So let's take it a step at a time. Negative 5 times negative 5, what is that going to be? We said negative times negative is a positive, so that's going to be positive 25, times negative 25, or sorry, not negative 25, but negative 5. Well, that's going to be 125, but it is going to be negative. So we get negative 125 here. Now, we have negative 2 times that, and then minus 8. Well, in this case, I've got a negative 2 times a negative 125. So a negative times a negative is a positive. Good. So 2 times 125, well, that's double 125, so that's going to be 250. So 250 minus 8. So what is 250 minus 8? It's going to be 242. So your answer for this one will be 242. G of negative 5 is 242. So you just plug in the negative 5 in there. And remember, you have to cube it first, then multiply, then subtract. Okay, last thing, it says h of x equals 5x minus 7, where h of 4x. So this time they're not just saying 4, they're saying an x too. So we're plugging that into x. Again, not into the 5, but into x. So we're going to say 5, and then we're replacing the x with 4x times 4x minus 7. So we have to do our 5 times 4x first. So what is 5 times 4? 20. Then we put our x there. Minus 7. Okay? And that's it. We're actually done from there. So you can see my answer for this one is not going to be like the others because it has an x in it. We can't combine the x, 20x, and the 7. We can't say that's, 13x or 13 because the 20 has an x and the 7 does not or 7 has no x. Those are not like terms. So that's why your answer is 20x minus 7. Okay? So that's how you do that one. So let's move on to lesson 19. Okay, this one is all about domain and range and finding the value of functions, okay? So a function versus a relation. So here's the deal. Function and a relation. A function is basically saying that for every x value, there is only one y value. So you're answering whether this is yes or no. Okay, I know the right yes or no kind of got cut off, but it's right yes or no, and then explain why not. Okay, so what you're looking for is a function, again, like I said, is for every x value or every domain, there's only one range. Okay, for every domain, there's only one range. So if I was to write that out in numbers, here would be an example of a function. 3, 2, 4, 3, 5, 4. Okay, you can see that the x values are not repeating, so that would be a function. This would be yes. Okay. No would be something like this that's a relation but not a function. Would be something like this. 3, 2, 4, 3. But then you have 3, 5. Okay, so if you notice, the 3 happens twice. Now, it doesn't matter whether the y value happens twice. Technically, on this one, I could also put like 6, 4, and see how the y's repeat. That's fine. That's still a function. But this is not because the x values repeat or the domain repeats. So when we look at this like web chart thing, where it's kind of showing graphically how it does it, you're looking for, is any of these have two different things coming from it? Like 3 goes to 3 and 3 goes to 1. Or negative 3 goes to 3 and negative 3 goes to 1. That would be not a function. If it does not have that, let me erase. Okay, then it is going to be a function if it doesn't have any that are repeating. And if you notice, yes, these two both go to 1, but they're not repeating. There's not two branches coming from each of them. So that one is a yes, because it's mapped onto exactly one input into one output. Okay, so maybe this will help us on the second one. What do you guys think about this one? Is this one a function, yes or no? Well, you should have gotten no. The reason why is this negative 2. Do you see how there's two branches from it? It's going to 8 and to 9. And again, it doesn't matter whether 5 and 1 go to 10. That's fine. But there's two branches coming from 1. So this one, is it a function? No. Because there's one input is mapped to negative 2 and negative and 1. So it just does not work. Okay? So that's for that one. Now there's another thing called, if you have actual graphs, you have something called the vertical line test. And what the vertical line test is the vertical line test says if you draw a vertical line, meaning an up and down line, everywhere it touches one of the blue parts or part of your graph, not the x and y axis, but the part of the graph, if it touches it in more than one spot, then it is not a function. If where you draw a line, it only touches it in one spot, everywhere where you draw a vertical line, then it is a function, okay? So kind of like the repeating. So if it touches it twice or more than once, it's not going to be a function. So what I mean is I draw a vertical line. How many times does it touch this blue line right here? Once. Okay, draw a vertical line. Once. This is the only tricky part. Okay, sometimes people would think that's 2, but really it's only 1 because this is an open circle. A closed circle means it includes that point. An open circle means it does not include it. So that still counts. Okay, checks here, they're not overlapping. If these were overlapping, then it would be no, but it's not overlapping. So everywhere I draw it, it's only once. So this one is going to be yes. This is a function. Okay, it passes the vertical line test. Now this one, okay, crosses once, but you can see as I draw the other ones, is it crossing more than once? Yes, it's twice in both of these spots. So anywhere, only if it's anywhere on the graph where it crosses it more than once, then it is not a function. So this one is no. Okay, let's look at the third one. What do you guys think before I even draw my lines? Is that a function, yes or no? No, it's not, because again, it does not work on the vertical line test. There's multiple places where it doesn't pass. And remember, this is where it's saying, you know, for example, on 0, there's 2 points for 0. So that's where the x is repeating. So it's the same as the other one when we were saying, you know, the x cannot repeat, or the domain cannot repeat. So this is yes, no, no for that. Okay, let's look at this one now for 4. Okay, now we're just looking at dots here. So let's see if any are crossing. That works, that works, that works, that works. Oh, what about this? 2. So even if it's in one spot, this one is a no. This is not a function. Okay, it doesn't pass the vertical line test. That works, that works, that works, that works. So this one is yes. Okay, let's look at the last one, a parabola. What do you guys think about a parabola? Is that a function, yes or no? It is a function, because everywhere you draw it, and I know my lines aren't perfectly straight, but even though it's curved, it's never going to cross it more than once. All of these are only really touching it once. So this one is yes, this is a function. So parabolas are functions, just like linear equations, like a straight line is going to be a function. Okay, so lesson 20. That was it for lesson 19, which is all about functions and relations. 20 gives you the x and y coordinates. So it says, give the x and y coordinates of Madrid. So they're going to ask you for a different one, but we're looking for Madrid. So we're just looking at where the x and y. Now remember, this is the x-axis. This is the y-axis as they have it labeled. So first, remember, our point is going to be x comma y. Okay, so x point goes first. So I have to go over and locate where my x point is. And if you notice, that's at -10. So that's going to be -10, comma. Okay, and then the y value, if you notice, right here, which is between 6 and 8, which is -7. So your answer would be -10.7. So you guys have to do it for one of them, but just realize your points. You know, do your x value first, like if you're doing burn, and then your y value, so that'd be 1, -3. Okay? That's how you do it. All right, the last one. Fill in the table using the graph. So you have to fill in the table using the x values. They give you the x values, kind of like what we did in the first part, and then you need to find the y values. So you're replacing -1 with x. That's your first thing you're doing. So you're saying y equals -3 times -1, because I'm replacing that, plus 4. So that's the first one. So what is -3 times -1? Yeah, that's going to be 3 plus 4 is going to be what? 7. So there's my first answer. So I put negative 1, 7. Okay, so that's my first one. So I put 7, comma. You just list off all the different numbers. And I'm just putting in a table first, but my answer I'll list out. So then I go to the next one. I say y equals negative 3 times what? What's my next number? 0 plus 4. Well, 3 times 0, or negative 3 times 0, is going to be what? Well, anything times 0 is just 0. So what's 0 plus 4? 4. So that's my answer. So 7 and 4. Now let's look at 1. I'm going to change color on this one so we don't get too confused. So we're saying y equals negative 3 times 1 minus 4. Well, what's negative 3 times 1? Oh, plus 4, sorry. That's going to be negative 3 plus 4. Well, those are different signs, negative 3 and positive 4, so we actually subtract. So 4 minus 3, 1. So that's going to be my answer. Okay, let's do the very last one. Y equals negative 3 times 3 plus 4. Well, what is negative 3 times 3? Negative 9. Plus 4. Different signs we subtract, and we keep the sign of the larger one. So the last one, when we did that, it was positive 1. But this case, it's going to be negative 5, because 9 minus 4 is 5, and we keep the sign of the bigger one. So when you write that, type it in, you'll just say 7, 4, 1, negative 5. And that would be your answer, but obviously this is going to be different numbers. But these are all problems to help you that look like the problems we did. So hopefully this is good.